Hi, I'm Oliver Smith, and in this tutorial I'm going to walk you through creating a small skeleton application for introducing you to the basics of Intel threading building blocks. I'm going to be doing this in Visual Studio 2008. I'm going to create a new project, a general empty project that I will call TBB test. I'm not going to create a directory for the solution. I'm going to be using the Intel C compiler, so the first thing I will do is switch over to the Intel C compiler. Now I'm going to add a source file to work with, tbb test.cpp. And now we're going to change some of the project settings. First of all, you're going to want to select all configurations, as the changes we're going to make right now will apply to all of your configurations. Under Language, enable OpenMP support, generate parallel code. If you're using the Intel compiler, you'll also want to make the following changes. Under code generation, Intel processor-specific optimization, if you're using an Intel CPU, set that to QX host. If your machine has SIMD instructions, SSC1 or SSC2, etc., enable those here. If you're using an Intel CPU, that'll be overwritten by the processor-specific optimization. Lastly, again, for the Intel compiler, this is an optional step, but you can add the command line /q tbb just to give the compiler a hint that you will be using the threaded building blocks libraries and features. Now I'm quickly going to flesh out the first pass of a pretty basic skeleton program. We're going to be standard IO for printf to print out to the console. We're going to be using the standard template library STL vector class for dynamic arrays, and we're going to be demonstrating TBB with the parallel sort algorithm. We want a main function, and save that. We're about ready to just test that and make sure that I didn't make any silly typos. Before we do that, there will be a few little things we need to do. If you didn't add the QTBB option to the Intel compiler's command line, or if you're using the Microsoft compiler, you will need to tell the linker to use tbb debug.lib, like so. If you added the QTBB, that will be added automatically. The next thing that we'll have to do, and this covers all of our projects and solutions, is to tell the compiler and linker where to find the various files it's going to be using. I'm building for x64, so first of all we need to add a path for the DLLs, and this will be in your programs folder in the Intel compiler location, TBB. And then if you're compiling 32-bit, it'll be under IA32, otherwise it will be under Intel 64, VC9, and bin for Visual Studio 2008. Include files are in pretty much the same location. C, programs, Intel, compiler, TBB, include. Now you want the include folder here, not the TBB folder. You'll see why. Well, because all of the headers use #include tbb/. And finally, the library files. Again, similar location, Intel compiler 1160 tbb. And this time the lib folder. Okay, and with that we should be ready to build. And as you can see, it's compiled. On the basis that you might want to use this skeleton for a number of different TBB tests, I'm going to quickly partition it into 4 logical subroutines. An initialization routine, and routine for populating the global data. Another routine for processing, testing. And finally, a routine for reporting on the execution. I'll just go ahead and flesh those out up here. So here you can see I've quickly just created my 4 functions: initialize, populate, process, and report. For this tutorial, what I'm going to do is create a very large array of unordered integers, and then we're going to use parallel sort to order them. I'm going to start by declaring a constant for the size of our array, and I'm going to say that there will be 1,000,000 integers. We're going to use a standard vector of integers for our storage. Call that integers, and I'm going to declare 2 of these vectors, one called myInts, which will store the unsorted integers, and we're going to have a second one called sortedInts, which is where we'll store the sorted results. And the reason for doing that, we don't have to do that, but that's purely so that we can compare the 2 at the end in the report function and see if anything was actually done. So our first step is going to be to just quickly to initialize the myInts, resize to the array size, which allocates enough elements for our 1,000,000 integers. And then we move on to the populate function. And for this, I'm going to use a very fast little routine which uses a couple of prime numbers to create a pseudo-random twister. What this will do is will generate a sequence of all the numbers between 0 to the small prime in a semi-random or seemingly random order. Given the same initial rand value, the sequence will be the same every time. You could just populate all the entries of myInts with a call to rand, but I wanted to make sure that the numbers were all unique, just to put some extra load on the sort call. Before I get into the final details of using TBB, I'm going to start by putting in a benchmark baseline by calling just plain old sort on the to be sorted integers. That will provide us with a baseline of functionality, and then I'm going to add some code to test that. I'm going to go through the first 8 integers in the myInts list and print those out so we can see what they were, and then I'm going to print the sorted ints list so we can compare the 2 and just verify that they did in fact change. And then finally I'm going to do an order check, and basically all I'm going to do here is go through all of the array entries, and I'm just quickly going to check if they aren't in increasing order, which would mean that sorted ints of I was greater than or equal to the next element up. Then we set is ordered to false. And then we finish by printing out whether or not we succeeded. Okay, that should give us a baseline program that we can just quickly compile, and then we can run.